Hello students. This video will be helpful to have an idea about nuclear hazards and human health risks. This video will be helpful for student to understand meaning of nuclear hazards, sources of nuclear pollution hazards, radioactive pollution, human risks, control of nuclear hazard, disposal of nuclear wastes and precautions after the disposal of nuclear waste. Nuclear hazards are threat posed by the invisible and odorless contamination of the environment by the presence of radioactive materials such as radionuclides in air, water or soil. These radionuclides emit high-energy particles, alpha and beta rays, and electromagnetic radiations, gamma rays. Radionuclides are elements such as uranium-235, uranium-283, thorium-232, potassium-40, radium-226, carbon-14, etc., with unstable atomic nuclei and release ionizing radiations in the form of alpha, beta and gamma rays. The spontaneous emission of particles and rays by an unstable nucleus is called radioactivity, and contamination of environment with these radiations is called as radioactive or nuclear pollution. Thus, radioactive or nuclear pollution can be defined as the release of radioactive substances or high-energy particles into the air, water, or earth, mostly as a result of human activity, either by accident or by design. Sometimes natural sources of radioactivity, such as radon gas emitted from beneath the ground, are considered pollutants when they become a threat to human health. Radionuclides occur naturally in our environment. They are even found in human bodies, and every day we ingest or inhale these radionuclides through air, water or food. Out of the known 450 radioisotopes, only some are of environmental concern, like strontium-90, tritium, plutonium-239, argon-41, cobalt-60, cesium-137, iodine-131, krypton-85, etc. These can be both beneficial and harmful, depending on the way in which they are used. Sources of nuclear pollution hazards. Radioactive pollution are as follows. 1. Natural sources. Most radiation exposure is from natural sources. These include radioactivity in rocks and soil of the Earth's crust, radon, a radioactive gas given out by many volcanic rocks, and uranium ore, cosmic radiations, etc. A. Cosmic rays from outer space. The quantity depends on altitude and latitude. It is more at higher latitudes and high altitudes. B. Emissions from radioactive materials in the earth crust, i.e. rocks, marine sediments, etc. 2. Man-made sources. These sources involve any process that emanates radiation in the environment. While there are many causes of radiation pollution, such as including research and medical procedures and wastes, nuclear power plants, etc. A. Nuclear waste handling and disposal. B. Use of radioactive materials in defense weapon production. C. Nuclear explosions and detonations of nuclear weapons. D. Mining and processing of radioactive ores. E. Nuclear accidents. F. Use of radioactive isotopes in medical, industrial and research applications. Radioactive substances, when released into the environment, are either dispersed or become concentrated in living organisms through the food chain. Other than naturally occurring radioisotopes, significant amounts are generated by human activity, including the operation of nuclear power plants, the manufacture of nuclear weapons, and atomic bomb testing. Typically, these effects can be of two types. 1. Somatic effects. Somatic affects the function of cells and organs of the individual exposed. It causes damages to cell membranes, mitochondria, and cell nuclei, resulting in abnormal cell functions, cell division, growth, and death. 2. Genetic effects. Radiations can cause mutations, which are changes in genetic makeup of cells and affects the future generations also. These effects are mainly due to the damages to DNA molecules. People suffer from blood cancer and bone cancer if exposed to higher doses around 100 to 1000 roentgens. Nuclear hazard effects can be either initial or residual. Initial effects occur in the immediate area of explosion and are hazardous immediately after the explosion. The principal initial effects are blast and radiation. Blast causes damage to lungs, ruptures eardrums, collapses structures, and causes immediate death or injury. Thermal radiation is the heat and light radiation, which a nuclear explosion's fireball emits, producing extensive fires, skin burns, and flash blindness. Nuclear radiation consists of intense gamma rays and neutrons produced during the first minute after the explosion. This radiation causes extensive damage to cells throughout the body. Radiation damage may cause headaches, nausea, vomiting, diarrhea, and even death, depending on the radiation dose received. Whereas the residual effects can last for days or years and may lead to death. All organisms are affected from radiation pollution, and the effects can vary from mild to extremely dangerous depending upon the various factors such as dose, duration, and type of radiation. Some of the possible human health effects are listed as under. A. Effects on DNA and mutations. B. General physiological effects. C. Effects on immunity. D. Effects on tissues of vital organs. E. Occupational diseases. F. Effects through biomagnifications. G. Cancers. Peaceful uses of radioactive materials are so wide and effective that we cannot go without them, but also there is no cure for radiation damage. Thus, the only option against nuclear hazards is to check and prevent radioactive pollution. Following are the ways to prevent or control these hazards. A. Leakages from nuclear reactors, careless handling, transport, and use of radioactive fuels, fission products, and radioactive isotopes have to be totally stopped. B. Safety measures should be enforced strictly and strengthened against nuclear accidents. C. There should be regular monitoring and quantitative analysis through frequent sampling in the risk areas. D. Preventive measures should be followed so that background radiation levels do not exceed the permissible limits. E. Appropriate steps should be taken against occupational exposure. F. Waste disposal must be careful, efficient, and effective. 1. High-level wastes. HLW high-level wastes have a very high radioactivity per unit volume. E.g. spent nuclear fuel. HLWs have to be cooled and are, therefore, stored for several decades by its producer before disposal. Since these wastes are too dangerous to be released anywhere in the biosphere, therefore, they must be contained either by converting them into inert solids, ceramics, and then buried deep into earth, or are stored in deep salt mines. 2. Medium-level wastes. MLW medium-level wastes, example, filters, reactor components, etc., are solidified and are mixed with concrete in steel drums before being buried in deep mines or below the sea bed in concrete chambers. 3. Low liquid wastes, LLW. Low liquid wastes, example, solids or liquids contaminated with traces of radioactivity, are disposed of in steel drums in concrete-lined trenches in designated sites. In India, a waste immobilization plant, WIP, was commissioned in 1985 at Tarapur. It verifies HLWs. Precautions after the disposal of nuclear waste are as under. 1. Monitoring radioactivity around the disposal sites. 2. Prevention of erosion of radioactive waste disposal sites. 3. Prevention of any drilling activity in and around the waste disposal site. 4. Periodic and long-term monitoring of such disposal sites and areas of naturally occurring uranium-rich rocks. Thank you for watching this video. Watch more videos like this on my YouTube channel all about economics. Thank you.